Hello, today's video is on momentum, both um, linear and no, we'll not be doing angular momentum, we'll just be doing linear momentum. So let's just get started. So, what is momentum? Momentum is nothing, it's a word given to the total motion contained in a body. Okay, so if a body is big or small, whatever motion whatever motion is contained in it is called momentum. Now, whenever you learn about any physical quantity, you need to know a few things about it, like what would be its unit, whether it is a vector or a scalar. So momentum, first, this you've learned in GCSE, is just mass times velocity. So the unit would be mass is kg, velocity is kg meters per second. Now, because momentum is mass times velocity and velocity is a vector, so momentum is also a vector. That means it has a direction and the direction is same as that of the velocity. Okay, so pause and just internalize this or learn that momentum is mass times velocity, kg meters per second, and it's a vector. Now, linear momentum, because it would be calculated only with linear velocity. We are not yet calculating the angular momentum. So whenever you can see in the animation, both the bodies are moving along x direction or horizontal direction, so they will both only have linear momentum, which is P equals mv. Okay, next, just calculating, trying to use the formula. The ball was bowled. Just after the ball hit the ball, bat hit the ball had this much velocity at an angle of 50 degrees to the horizontal. Okay, just for the name's sake, always draw the diagram. It helps you to understand some complicated problems. So let's say 23.8 meters per second at 50 degree to the horizontal. Show that the magnitude of the momentum of the ball, so this is what you want to calculate, so I'm just writing P, after it was hit was about 3.3 Newton second. Why Newton second? Because, okay, I'll tell you in a minute. Let's just figure out right now what was the momentum. So I'm just using m times v. M is 0.140 times v is 23.8. Now, because velocity is in this direction, the momentum will also be in this direction. Momentum is exactly same direction as velocity, so I'm using my calculator. Just give me 1 minute. Okay, so it's 0.140 times 23.8, which is 3.332. So it is coming as 3.3332, which is equal to 3.3 Newton second. Now, why Newton second? Is because there's a relation between force and momentum, which is given by the Newton second law, which is defined as, so the resultant force acting on a body is rate of change of linear momentum, or in the differential form, dp over dt. So from here, if you calculate the unit of momentum, your force is in newtons and then you times it by time. So Newton second is the unit for change in momentum, which is also the unit for momentum. So okay, units. So another unit for momentum is Newton seconds. The first one we saw was the basic standard SI unit, and the other common unit is Newton seconds. Now from here, as you can see, the resultant force is change in momentum over time. So if resultant force is 0, okay, that means there's no resultant force acting on a body, the change in momentum is 0. So if change is 0, that means the final momentum is equal to the initial momentum. Okay, if resultant force is zero, the change in momentum is zero, final momentum is equal to initial momentum. That's it. So that means if the total mass increases and the resultant force is zero, the velocity would decrease. I'll give you an example, not the increase of mass. Let's say, for example, when a space vehicle is fired and it carries some satellite, or it is carrying something to the different planets, then what happened is, as the space vehicle is launched, it gradually, the mass of that space vehicle is decreases. The reason being, it is burning up the fuel and it is ejecting the parts which contain that fuel, so it decreases mass. And once it is out of the gravity, Earth's gravity, the resultant force acting on that space vehicle is almost zero. So if the mass decreases, the velocity would increase. Why? Because the momentum is conserved. Why the momentum is conserved? Because according to Newton's second law, the resultant force is zero. So whenever we say something, the change of something is zero, we say that thing is conserved. So the momentum is conserved. What's the condition for conservation of momentum? Is that the external resultant force should be zero. Okay, now let's see. A footballer kicks a football from a penalty spot and draws a graph between force, so force and time. A graph is drawn. What would the area under the graph represent? Now, I don't know what's the shape of the graph. I'm just drawing any shape to make you understand. So if I calculate the area under the graph, what would that give me? So if I'm calculating the area, obviously what I'm doing is I'm multiplying the y with the x in some form. In some form, I'm not saying exactly multiplying. If it was a straight line, it would be a triangle. If it's like this, it would be a rectangle. Whatever form it is, you'll end up multiplying y with x-axis. So when you're multiplying force and time, work on the unit. Newton's times second. What is Newton's times second? Change in momentum. So that's your answer. Okay, so this is again for, let's just go back here and let's just record here. So if I have a graph between force and time, let's say I'm just taking a straight graph here to make you understand. The area under the graph is going to give you the change in momentum. So area is change in momentum. Okay. So conservation of momentum, what's the condition for conservation of momentum? Resultant external force is zero. So whenever this is zero, the change in momentum is zero. Now, the kind of questions that you get in A-level physics is based on collisions, some sort of collisions. So in collision, we assume that the resultant force is zero because the collision is acting, the time of collision is so small that in that duration we can assume that the resultant force is zero. So the resultant force is zero, so the momentum is conserved. That means the total momentum before collision is equal to total momentum after collision. Okay, so I'm just going to write here, so total momentum, so P is for momentum before, is equal to total momentum after. Okay, so the two types of collisions that you have is elastic and inelastic. Okay, elastic and inelastic. So now so if it is an elastic collision, there's no energy loss. Okay, no kinetic energy, let's be precise, no kinetic energy is lost. And because no kinetic energy is lost, then what did I tell you? Anything, if it is not lost or it does not change, that means it is conserved. So kinetic energy is conserved. Momentum is always conserved, whether it is elastic or inelastic, because it's collision. In collision, the external force is assumed to be zero, resultant force is assumed to be zero, so momentum is always conserved. In elastic or inelastic, both the cases momentum is conserved. in elastic, no kinetic energy is lost, but in inelastic, kinetic energy is lost to deform the shape because it's inelastic, right? So there will be some deformation in the shape. So the kinetic energy is lost in the form of potential energy. So see, can you see the two cars are sticking together? If they're sticking together, that means there is some change in shape. So whenever there's a change in shape, there's an increase in elastic potential energy. So kinetic energy is lost in the form of elastic potential energy, but in elastic collision, no kinetic energy is lost. Okay, now let's see. Which of the following is always true for an inelastic collision? Pause and figure out. If you've done that, the answer would be both momentum. Okay, so this is not right. Momentum is conserved, but kinetic energy is not conserved. Conserved means it will not be lost. Neither momentum or kinetic. This is conserved. This is right. Said kinetic energy is not conserved, momentum is. Kinetic energy is not conserved, so that's your answer. Because momentum is always conserved. We don't want a word not here. Okay, try this one. A bullet is fired into a block of wood. Select the line that applies to this situation. A bullet is fired into a block of wood. Will there be a change of shape? If it is a change of shape, the collision would be inelastic. So when the collision is inelastic, is the kinetic energy conserved? No, it's not conserved. So both of them are right. Momentum, always conserved. So that's your answer. Momentum is always conserved. Let's do this one. Two identical pairs. Now, what has done is this is qualitative. Now this has turned into quantitative. They want you to do some kind of equations, algebra, and then figure out. So identical pairs of mass m. So this one is mass m. So what's the momentum for this one? mv. But the momentum for this one is minus mv. Why? Opposite direction. Remember, momentum is a vector. So at the start, so this is a start. So what's the start total momentum at the start? So start total momentum of both the bodies would be mv plus minus mv, so 0. So total momentum of both the bodies in the start is 0. So what should be the final momentum? It has to be 0 because momentum does not change. So what is the answer? Which of the following must be true after the collision? After the collision, total momentum is 0. Okay. Now, the kind of questions you would generally be having in A-level physics is either the momentum would be conserved in one dimension or two dimensions. So first, let's see if it is one dimension. Okay, let's start with the first question here. So two objects A and B are moving along a straight line. So we have two objects. Always make your diagrams, rough diagram, okay? Moving along a straight line, object has 2 kg mass, so this is 2 kg, and 6 meters per second to the right. This is 3 kg, and this speed is 0. So what's the starting momentum? So 2 times 6 plus 3 times 0. So this is 12 kg momentum. So starting total momentum is 12 kg meter per second. Okay, now let's see. They collide, and after the collision, so after collision, make another diagram. Object A moves. Now see, the speed of this one has reduced. So that means the momentum has reduced. So where has the momentum gone to? It must have gone to what? 3 kg. So we don't know what would be its velocity. Okay, now let's see what the question is asking. State the principle of conservation of momentum. What's the conservation momentum? Okay, if you feel like trying it yourself, always pause and try it yourself. So principle of conservation momentum means total momentum before is equal to total after, or the momentum remains unchanged during the process. So total momentum before is equals to total momentum after, or the momentum does not change. Okay, whatever you feel like, right? Now calculate the velocity of object B immediately after the collision. So this is what we have to calculate. So now after, what is the momentum of this one? 2 times 2. And what's the momentum of the second one is 3 times V. Now what happens is when you're learning new things, your mind is so busy thinking about this new thing that it forgets what you were actually doing. And then if you draw a diagram, see, because my diagram was there, the minute I read this question, I came back to this diagram and started doing it. If I would not have made this diagram, I would have to go back to the question, reread it, and then do it. Okay, just take it slow. Initially, there's no harm in doing it slowly, making diagrams and moving on. So 12. Now, because my momentum is conserved, momentum before is equals to momentum after. So I'm just equating them equals to 4 plus 3v. This will help me. 12 minus 4 is 8, 8 over 3. So my answer is the velocity of B is 8 over 3 meters per second. Okay, I'm just going to use my calculator. So I'm getting 2.67. So I'm going to, oh my god, okay. You know, surprisingly, this 67 is the most common number which always comes up in whatever you're doing. Whoever started this thing was really intelligent. Okay. Determine whether the collision is elastic or inelastic. Show your reasoning clearly. Now, to find whether the collision is elastic or inelastic, the only difference between the two collisions is the kinetic energy is not conserved. So what I will have to do is I have to find the starting kinetic energy. So KE is how much? The first is, I'm just using half times mass times V square. So half times 2 times 6 square is 36. And the first one was, the B has 0. And after, I'm taking after is the second one, half times 2 square is 4 plus half times 3 times 8 over 3 square. So just use 8 over 3 because otherwise you'll end up having a rounding error. So half times 0.5 times 3 times I'm getting around 10.7 plus 4 is, so this is, I'm just going to write it here because I started writing it. Where's my pen? I guess, sorry. This has become really slow now. So 10.7. So this is around 14.7. So clearly kinetic energy is not conserved. Hence, what kind of collision? Inelastic collision. Calculate the change in kinetic energy. So 36 minus 14.7 is the change in kinetic energy. 36 minus 14.7, which is 36 minus 14.7 is 21.3. So 21.3 joules. Explain in terms of energy transfer what has happened to the kinetic energy during the collision. So this kinetic energy, 21.3 joules, kinetic energy has decreased and has gone to deforming the two objects and also as thermal energy to the surroundings. Now we're continuing with the same question, only this time it has given us the collision time. So the collision time is 0.02. So what's the average force acting on A? So remember, force is change in momentum over time, and change in momentum for A. How much? So the starting momentum of A was 12. So now we need to calculate only the momentum of A because it's asking the force of A. So the momentum of A starting was 12 and the momentum of A after was 4. So 12 minus 8. So the change in momentum is then 12 minus 8 and the time was 0.02. So 4. Is it 8? No, sorry, I think I made a mistake. It's 4. I wrote the answer here. So 4 and this is 8. So 8 divided by 0.02 is 400 newtons. But now what direction? Let's see. Let's go back. What do you think? It was initially moving at 6 towards right. After collision, moves at 2 towards right. So what direction must the force be acting? Opposite. That's why the speed is decreasing. So the force is acting towards the left. You will have to reread, go back to the question many times if you have this many parts. It's not possible to remember the entire question. Drawing the diagrams would help, but you will still have to go back to reading the question over and over. Okay, next is 2 dimensions now. So this is, if it is 2 dimensions, you will have to conserve momentum in both the directions because the resultant force is 0 in both the directions. Let's just see this one. A smooth horizontal surface is frictionless. So this horizontal surface is frictionless. 2 pucks collide and move off in different direction. Puck A has mass 0.5 kg. So I'm going to first make a x direction. So I have a puck which is 0.5 kg and is initially moving at 8 meters per second. So I'm going to calculate the initial momentum here, which is 8 5s are 40, so 4 kg meters per second. A puck B initially has a mass of 0.4 kg, so 0.4, and is initially at rest, so the initial momentum is 0. After the collision, puck A moves 5 meters per second, so I'm going to make diagram here. So this is my puck A moving at 5 meters per second at 30 degree to horizontal. Puck B moves V at angle theta, so B, so this is A and this is B. It is moving at V angle theta to the horizontal. Okay. Why momentum must be conserved separately in the x and y direction? Because the resultant force is 0 in both the directions and momentum is a vector quantity, so you need to conserve separately in both x and y direction. Resolve the velocity of puck A after the collision into x and y components. So puck A was the x component. So this one here is 5 cos 30. Use the right angle triangle, and the y velocity would be 5 sine 30. Okay, I'm just doing it here. Okay, so if you have a right angle triangle, this is 5 and this is 30 degrees. So the horizontal is always cos, the side touching is adjacent, right? So cos, and the perpendicular side is sine, 5 sine 30. So my vertical component is 5 sine 30. So y direction, it is 5 sine 30, which is 0. No, sorry, not 0. 2.5. Okay, remember the side touching the angle is always cos. So this side was touching the angle, hence it is cos. Okay, then x direction is 5 cos 30. That is, so you need to just need to do that. 5 so that is around 4.33. So no, how did this happen? Yeah, so most of the component is in the x direction, so 4.33 meters per second. So we got the x component and we got the y component. This is what was asked. Okay, let's do the next part. Oops, what did just happen here? All right, so the next part is using the conservation of momentum in both directions, determine the speed v of puck B. Okay, so now let's just go back and see what was the x direction momentum of A is 4. Okay, so I'm conserving in x direction first. So at the start, the momentum was 4. Okay, and then what was the momentum of the A after collision in x direction is 0.5 times 4.33 because that's the velocity. So I have to times this with 0.5. Yeah, say this one is equals to 0.5 times, what's the speed? Sorry, I have to go back. So this is 4.33, and then this one will also have 0.4 kg. Will have, so this component of v will be in this direction, will be v cos theta. Okay, so I'm just going to go back and then write 0.4 v cos theta. I'm just going to draw the diagram here. This is going back is too much. So this is 0.5, and the velocity was, how much was the velocity? We had the velocity here. So this is 5, 30 degree, and then this one is v at theta. So this velocity would be v cos theta, and this one would be v sin theta. Okay, now I'm just solving for this. So this will give me 4, sorry, I'm just simplifying this to get, this is going to be a lot of algebra here. Okay, but if you're doing AQA, you don't need to do the 2 dimensions thing. So that's a good news. So but it is required for Excel definitely. Right, so just using my calculator now. So this is giving me my v cos theta comes out to be 4.59 meters per second. Now I'm conserving the momentum in y direction. Okay, as previously told, if you're doing AQA, you do not need to know this. You do not need to practice this kind of question because they won't come, but at Excel, yes. OCR, yes. Okay. All right, so now, so in y direction, the initial momentum was 0 because my puck was only moving in positive x direction. And then the final momentum of 0.5 kg is 0.5 times this one, which is 5 sine 30. We already calculated. So that is 2.5, and this downwards is 0.4 v sine theta. So this one is going to give me 0.5 times 2.5, that is this, then divided by 0.4 is 3.125. So I'm getting v sine theta as 3.125. Okay, just to get rid of my rounding error, this is what I'm doing now. It's asking you theta and speed, so I'm just dividing both of them. So if I divide this and this, I'll get tan theta. So I'm just writing here, so my tan theta is then 3.125 divided by 4.59. And then to calculate the angle, would say. So this is giving my angle as 32.5 degrees. So this is giving me my theta as 32.5 degrees. And once I've got my theta, to calculate the speed v, I'm just squaring and adding these two equations. So this and this, if you square and add, you'll get and take a square root, it'll give you v. So I'm just writing it here in case you're not very good with that kind of math. So v will be under root of 4.59 squared, because it's using the right angle triangle, plus 3.125 squared. That is giving me answer as 5.55. So writing up to, yeah, so meters per second. So we got the angle, we got the velocity. Show that the kinetic energy is not conserved in this collision. So you calculate total kinetic energy after collision and before collision. So I'm calculating first kinetic energy, say KE before collision is 0.5 times 8 squared times 0.5, so 0.5 times 0.5 times 64 is 16. So before collision is 16 joules, so 16 joules, and after collision is both. So okay, so the first one is 0.5 times 0.5 times 5. Remember, kinetic energy is not a vector, so you don't need to calculate, you don't need to consider angle, so just calculating the speed, and the final speed of this one is 5.55. So 0.5 times 0.4 times 5.55 squared, execute 6.7 plus. Understand the method. These numbers are of no importance here. Say so I'm getting 12.415, and say because the kinetic energy is not coming same, that means the kinetic energy is not conserved. It is lost in the collision. The lost kinetic energy is used for, because the surface is frictionless, it has gone into changing the shape or deforming the shape of the two pucks. That's why it is inelastic. Okay. Now this one is again a two-dimensional question, but I think this one is from the exam board. This is from Edexcel. So student carried out experiment with coins. She arranged a collision between a 2p coin and a stationary 1p coin. Okay, so there's a 2p coin, 1p coin, and then this is another 2p coin. Show that the velocity of 2p just before the collision was about 2. So this one we don't know now. This one is, let's say, x. See, the starting momentum of x of 2p is 7.1 x. I could change the mass into kg, but because my entire equation would be in grams, it would not matter. Now, what is the momentum of this one in x direction? So this is 3.6 times 1.4 times cos 10. Remember, the side touching the angle is always cos. And then this one would have plus 2p is 7.1 times 0.9 times cos 8. So that's my final momentum in x direction. So equals, so let's just add them. Okay, I'm just going to add it here so that it becomes easier for you to see it. Okay, let's just see. 3.6 times 1.4 times cos 10 degrees. Okay, then plus 7.1 times 0.9 times cos 8 degrees will be this. So I got 11.29 is the total. So this one is 11.29 something something. So I'm not writing the whole number, but I'm going to divide entirely by 7.1 to get rid of my rounding errors in my answer. So answer is 1.59. So the speed of x is 1.59. So this one is moving at a speed of 1.59 before the collision, which is almost 2 meters per second. So I've done nothing. I've conserved the momentum in both x direction. Initially, the x is 7.1 times x. We don't know how much is that for. We added 1.4 cos 10 degrees and 7.1 cos 8 degrees times 0.9. You will have similar question in OCR too, because they are also very simple kind of questions. Not very complicated questions. You can pause the video, rewind, whatever. Just keep practicing, and we will do the next video probably on circular motion. Right? Keep watching, keep learning. Well done. Bye bye.